Hello everybody, getting ready to do lesson 4.7, part 1, pre-calculus math, inverse trig functions. The classwork today will have 4 points of notebook taking, and then 36 points goes on your classwork sheet. Part 1, 4.7, inverse trig functions, evaluate and graph inverse and sine functions. Evaluate and graph other inverse trig functions. Evaluate compositions of trig functions. Today's Bellwork teachers, for your students, simplify these radical expressions here. Give your students about 3-4 minutes for that. Okay, welcome back for the solutions of today's Bellwork. For the first Bellwork up here, with this simplified, you need to rationalize your denominator, so you end up with 1 over the square root of 2, and again you need to rationalize that because you cancel these out, so you end up with, after you rationalize your denominator, you end up with radical 2 over 2, and then down here for this one, again you need to rationalize your denominator, and you end up with 2 times the radical 3 over 3. Okay, notebook entry here, inverse sine function. Recall from section 1.6 that for a function to have an inverse function, it must be 1 to 1. That is, it must pass the horizontal line test. So you have a sine curve like this. So it is obvious that y equals sine x. It does not pass what is called the horizontal sine function because different values of x yield the same, does not pass the test because different values of x yield the same y value. However, when you restrict the domain to an interval such as negative pi over 2, less than or equal to x, less than or equal to pi over 2, corresponding to the black portion of the graph, the following properties hold. So you would get a 1 to 1 on this interval here. On the interval negative pi over 2, the function y equals sine x is increasing, and then on the interval of negative pi over 2, y equals sine x takes on its full range of values. So a negative 1 would be less than or equal to sine x is less than or equal to 1. So that'd be the full range of its values there. So again, further on your notebook, 3, on the interval negative pi over 2, y equals sine x is 1 to 1. So on the restricted domain of negative pi over 2, less than or equal to x, less than or equal to pi over 2, y equals sine x has a unique inverse function called the inverse sine function. It is denoted by y equals arc sine x or y equals sine to the negative 1x. The notation sine to the negative 1x is consistent with the inverse function notation f to the negative 1 of x. The arcsine x notation, read as the arcsine of x, comes from the association of a central angle with its intercepted arc length on a unit circle. So arcsine x means the angle or arc whose sine is x. Both notations, arcsine x and sine to the negative 1x, are commonly used in mathematics. So remember that sine to the negative 1x denotes the inverse sine function rather than 1 over sine x. The values of arcsine x lie in the interval negative pi over 2, less than or equal to arcsine x, less than or equal to pi over 2. So from negative pi over 2 to pi over 2 over here, 1 pi over 2, and then this is negative 1 down here, and this is 1 up here. So on this interval here, the values of arcsine x lie in an interval. The graph of y equals arcsine x is shown. So this is on your classwork sheet here. This is a really important part of this section. So, definition of an inverse sine function. The inverse sine function is defined by y equals arc sine x, if and only if sine y equals x, where negative 1 is less than or equal to x, is less than or equal to 1, and negative pi over 2 is less than or equal to y, less than or equal to pi over 2. The domain of y equals arc sine x is negative 1, 1, and the range is negative pi over 2, pi over 2. When evaluating the inverse sine function, it helps to remember the phrase that arc sine of x is the angle or number whose sine is x. That would be one way of stating the inverse sine function. The arc sine of x is the angle or number whose sine is x. So let's get into an example of this. If possible, find the exact value. So arc sine of negative 1/2. So because sine of negative pi over 6 equals negative 1/2, and negative pi over 6 lies in this interval here, negative pi over 2, pi over 2, it follows that arc sine negative 1/2 equals negative pi over 6, whose whose sine is negative 1/2. So negative pi over 6 would be the angle, would be the radian measure of the angle whose sine is negative 1/2. Now the sine to the negative 1 of square root 3 over 2. So because sine pi over 3 equals square root 3 over 2, and pi over 3 lies in this interval, it does lie in the interval, it follows that angle whose sine is square root 3 over 2. So when you have a unit circle here situation with this grid here, see sine to negative 1, 2. It is not possible to evaluate this function here, y equals sine to negative 1 at x equals 2, because there is no angle whose sine is 2. Remember that the domain of the inverse sine function is negative 1, 1. So when you're trying to take a sine outside this interval here, it's not possible. So let's get into some examples here. Find the exact value of each expression without using a calculator. So for arc sine 1/2, arc sine 1/2 is when sine y equals 1/2. For this interval here, y equals pi over 6 would be the radian measure for sine y of 1/2. And then arc sine 0, in this interval here, y would equal 0 for arc sine 0. Y would equal 0 as well. If you need to, you could use like a unit circle to visualize that. Okay, so sketch a graph of y equals arc sine x by hand. By definition, the equations y equals arc sine x and sine y equals x are equivalent for this interval, so their graphs are the same, sine y equals x and y equals arc sine x. In this interval here, negative pi over 2, pi over 2. You can assign values to y in the second equation, a table of values. So y, and then x equals sine y. So negative pi over 2 is negative 1, negative pi over 4 is this. This is a 45 here, and negative pi over 6. This is a 30-degree angle here, 0, 0. Pi over 6 is 30-degree angle. Pi over 4, again, you just repeat this over here, but they're positive. Then plot the points and connect them with a smooth curve. So when you plot these onto a grid, this is what you get. The resulting graph of y equals arc sine x is shown. Note that it is the reflection in the line of y equals x of the black portion of the graph. So this is what would be the black portion of the graph here. So like this here is kind of a blow up here of what's going on with x equals sine y. And then again, you have this here to give your y equals x here. Note that it is reflection in the line y equals x. So y equals x is a direct, it's called a direct function of y equals x between y equals x, and it's a reflection here on both sides of the origin. It is reflected in this line here. Okay, let's try one. Graphing arcsine function. Consider the function y equals arcsine x. Use a graphing calculator to complete the table. So, in this situation here, negative 1.0, this would be your numerical value here of y within this function here. And then continue here on the positive side, you would get these numbers as well here for x and y. And then this is what your plot would look like from this table here. You could use a scatter plot on your graphing calculator from that. And then C, use the graphing calculator to graph the inverse sine function, and then compare the result with your hand-drawn graph in part B. So for your hand-drawn, for that, go back into it, and that's up to you to finish. This is 4.7 part 1, pre-calculus math. Email me here for questions or for extra classwork sheets, homework sheets. Thank you very much.